So they're done already?
Well, they had like a test.
Oh, okay.
Usually I'll wait for him out of there, but also
Really?
just another opportunity to tell him he needs to get his license so he can drive just to see
Yeah.
Okay, so let's we'll move on to 5.1 here, where we'll talk about these radical expressions and functions, however that's what they title it. All right. So when radicals are the same as roots, basically. So we're talking about like square roots and cube roots and whatever other root. They focus a lot on mainly the square roots and the cube roots. So there's a couple things that would really help, I think, for you, and you might be pretty good at this already, but if you know all of the squares, it's pretty helpful. So I'm kind of writing them down here. Yeah. Okay. It's just kind of helpful to know those. Yeah. And also the cubes, if you know some of those. Okay, so these are your squares here. And the cubes. So if we know some of those. And I don't think you have to know a lot of them, but it kind of helps to know. Probably about the first 5 maybe. I don't know. Particularly like the first 3 would kind of help. All right. Just have it someplace, or at least kind of have an idea what they are. All right. So those are squares and cubes. I wouldn't worry about 4th power ones at all. So a radical, again, is just going to be a root of some type. And tonight all we're going to do is just kind of introduce to them. I'm looking to see if they have a list of them in the book, but I don't know if I see it. Nope. Okay, so there's a couple different things. I'm just going to start out a little bit from the bottom and then work our way up. So let's talk about simplify first. So when you simplify a root, say like a square root, and this is say 48. All right. What we want to do is break it down. And I can't remember, I think there's one previous class you've had that they do this, but I can't remember which one it is. So, but you want to break this down by finding the largest of the square roots that will divide into 48 evenly. So that's what we're trying to accomplish. We want to find the largest one that divides into this evenly. So we'd have 4 obviously goes into 48. 9 does not. 16 goes into 48. And since we have 25, 36, and 49, none of those are even going to come close to it. So we're going to go with 16. 16 goes in there 3 times. Everybody agree with that? Yep. We're good there. Okay, so then what you do is you take the square root of 16, which happens to be a perfect square. So that's 4. So the 4 comes on the outside, and the 3 stays on the inside. Okay, and that's called simplifying a square root. All right. So if we had the square root of, here we'll do 28. So we want to find the largest perfect square goes into 28. So we go down our line, right? Which one's the largest one that goes into 28? 9 doesn't go into 28.
Oh.
It's okay, we were in that together.
I was thinking 27. 27.
I know you were. Sure.
2.
4 goes in there how many times? 7. Okay, so then you take the square root of 4, which gives us 2. 2 pops on the outside and the 7 stays on the inside. All right, so that is the simplifying a square root. Okay, and this is also known as an exact answer because it's giving you an exact answer for it. All right, right beside it, I'm going to use the word evaluate. Now, evaluate is going to be a little different. When you take the evaluate the square root of 48, you actually use your calculator to come up with what the square root of 48 is. Okay, so that's the difference. So the square root of 48, well, it kind of depends on the calculator that you have.
6.928.
Sweet.
Yada, yada, yada.
6.928, and it keeps going, right?
Yeah.
So that's an approximation.
Yeah.
Okay. So the evaluate gives you an approximation, which is this, and simplify gives you what's called an exact answer, which is that. Okay, because 4 square root of 3 is an exact answer. Okay. Same thing happens here. Square root of 28. What is that equal to, or approximately equal to?
5.291.
Okay. All right, so there's a difference between when you see evaluate or approximate and when you see simplify.
Are the squiggly lines important?
Squiggly line means approximate,
Okay.
usually.
Yeah, that's what I
Okay, or about, yep. And so when you're, and then when I ask, yeah,
On the TI-89, it gives you the simplified answer.
right.
How do you change that?
Try diamond, the green, the green diamond. Is it green on yours? And enter. Did it work?
Yeah, it did.
Okay.
How about on one of these things?
Let's. There is a way. I'd have to look at that though.
Just gotta-
I don't know off the top of my head.
Yeah. Evaluate.
Ours is like just
Yeah. You just put it in.
you just hit second for the square
Yeah.
side.
And then make sure you close the bracket.
Okay.
You don't even have to do brackets. Plus it's a
Brackets?
negative number.
Right.
Well,
When you put in the square, it automatically.
I just put it in and
puts
puts
it.
some I'm sure that's something else. Just adds that.
That is not what mine was telling me.
Oh, there you go.
I wonder if yours is in a different mode.
Probably.
It probably is.
Oh, yeah, no, it's-
There's a way to fix it
I
though.
probably did it that way on purpose when I was in Math 65.
I'll try fixing it for you.
Let's see.
Although, I don't think I can get the simple.
Okay. Are we doing okay?
Our problems are probably going to be as easy as these.
Some of them are.
Is there a way to get the the simplified answer on the 83 plus?
83 and 84.
Because you get the exact or the evaluated answer.
I'm not sure that there is. I don't know.
What are you getting? Because I get the exact answer, but I can't get like the.
No. Oh, you're getting the exact answer.
Yeah, and I'm wondering how I get the 4 with the square root of 3.
Oh no, you're getting the approximate answer.
Yeah, I'm getting the approximate. I'm looking for the exact. Yes.
What's he, which one does he have? He has a 83, and I have an 84. And we can get these, the evaluate, okay, the simplify. Do you have a mode? Change your mode from exact to approximate. Scroll down.
Okay. calculator.
Gotten you this far.
Oh, there you go.
Okay. What about this then? Let's just do this. We're going to continue. Let's do this. Now we're going to still simplify. All right, but this time I'm going to make it a cube root. All right, so let's simplify the cube root of 16. Okay, so now we want to find a perfect cube that goes into 16 because it's a cube root. So what's a perfect?
Are we still evaluating? Or
No,
are we just
simplifying. The first column is going to be simplifying right here.
2.
Well, 2 is not a perfect cube.
8.
8 is,
Oh,
all right?
sure,
So
sure.
8 is, and it goes in there. How 8 goes into 16? 2 times. Now the cube root of 8 is 2. So the 2 pops out in front.
Right.
This is a cube root, and this 2 is right there. All right? That's simplifying. All right? That's simplifying. You're getting an exact answer. Okay. Cube root of, let's go with 32. So what goes into 32? That's a cube root. 8 again. How many times? 4. So that's going to be what for an answer? 2 cube roots
But that's not done.
4.
Is it?
Yeah, because it's a cube.
It's a cube root.
But the square root of 4 is 2.
Yeah, but you're not asking for a square, it's asking for a cube.
Well, you've already extracted the cube.
Yeah, you're done.
So you don't take it any further?
It's still a cube root.
Okay.
Okay. All right. That's confusing. That's why we did that one. All right. Now we will approximate or calculate or evaluate the cube root of 16. Okay. So this does kind of depend on what kind of calculator that you have here.
I have no idea how to do it on mine.
Scientific, that's what I want. Okay, so, oh man. All right, so what I'm looking for is a root with xy on it. This calculator doesn't even have one, I don't think. Oh, yes, it does. So what we're looking for is something like this, a root with a y and an x, something like that. Okay. Now a TI-89. Oh, I think we have to search for that. I believe on an 83 and an 84, you go math. There's a math button there, right? If you push that math button, you'll see this one. It'll be there. Okay. Who has the 80? You have an 89.
I have 84.
Yeah, you just push the math
Yeah,
button.
I figured it out.
Okay, on yours, I think there's a math button right there. You'll see the math button. See that?
Oh, yeah.
So I think you go to number. You might have to. Where is it? I know there's one right there.
I have to calculate. You got a calculator or color calculator? I can do it on.
Yeah. Where's that one at? I'd rather show. I can show. You know, I can show it to you.
Yeah.
Taking the answer of your last
Dude,
calculation.
don't even pick on my own math calculator here. It's right there, see? It's
There's
all-
cube roots right
Yep,
there.
it's all right there.
Now, if you want a different root, you use that one.
Yep, exactly.
Okay.
See, I see my own color calculator. Yeah.
So here, do a root.
I'm just saying. You can
No
look where
root
we're
button for it, but there is a way. So we're gonna do a cube root
Oh, because that's the shit. See, there we go.
16. We'll go like this, 16.
That's it. See, this is not a complex. And, see this right here? This goes from fraction to decimal. By taking that and this, bullshit, this.
See, now yours is giving it into like weird.
Seriously, it's a 12 can't see.
No,
So, change the mode or go like that. Okay, so on here I think I got to push the 3 first, then that button, and then the root, I believe. Nope, got to be the way. Sorry. So 16, that button, 3, enter. There it is, 2.519, right?
Yep.
And I think you can also do it. You can also do it in decimals. There's a way. I have to pull it up, but I know there's a way. All right. And so we can do the same thing with the cube root of 32. What does that give us? Let's try that one out.
Are you gonna get mad at us if we do this in our calculator rather than try and solve it out?
No, because it's an approximate. You're approximating, or you're not simplifying.
Right.
Okay, so we're approximating or evaluating. So you want to use your calculator.
Is there any? Okay.
Okay.
He said
What did we get?
3.174 or 175.
175.
Okay.
Approximately.
All right. What's that?
Can you pull it up in decimals?
Yeah, I can. Okay, so in decimals, it's if you go to functions over here, all right, and then you see where it says trig, stats, and miscellaneous. Push the miscellaneous, and then right down there, there's an N with a, right? You see that? Did I go too fast? It looks like a check mark with an N there. Underneath miscellaneous. You want miscellaneous.
Got it.
So you click on the. So I clicked on the. Like I'm going to type in a function, right? Okay. And then I went up down here to functions.
That makes sense.
And then I went to miscellaneous, and then the third one down from the miscellaneous is a check mark with an N. And if I click on that, what I have to do is tell it what the root is first. So that would be 3. So I'm going to click on a 3, and then I click inside the root, and I would put down whatever it is, and then it tells us. Okay? Yeah? You're welcome. That's how you do it there. Okay. All right. I want to go back to this guy, though. Okay. So, we simplified, we calculated, all right? But the simplification ones get a little bit tougher than that. So, let's take a look at that. So, now we're still back on to simplifying. Okay. So we're going to go like this. I'm going to stick with a square root for right now. And I'm going to go with 54x to the 4th. All right? So what I want to do is find the largest perfect square that goes into 54. I'm still going to break that down. What's the largest one that goes into 54? 9 does? 9 goes in there how many times? 6. Okay, so the 6 is going to stay underneath the square root, and then what's going to be on the outside as far as the number is concerned? 3. But I also have the square root of x to the 4th, right? Okay, So if I square root that, what do you think the square root of x to the fourth is? X squared, right. So the x squared is going to pop out in front. And that's done. Okay, so you take the break down to 54, take the square root of x to the fourth, which is x squared, and that comes out front. So anything that takes on that like square, that's what we're going to do. So like here, I see one in the book where it's something like this, x minus 3 squared, but we want to take the square root of that.
You just make it x minus 3.
It's just x minus 3, right. Okay. So anything that has a square on a square root, we're just going to do that.
So that's the answer?
Yeah, that's it.
Okay.
What if we have the cube root of a negative 64? And we want to find that answer. So now we're bounced back to cube roots for a while.
16.
You can't have a negative.
Or,
You
yeah.
can't have a negative
16.
square.
Yeah?
Yeah, you can, or yeah, you can't.
Well, let me ask you this. If you took, well, first of all, what's the cube root of 64?
8.
No, that's the square root.
That's
4.
4, right?
Oh, we're doing
So if we take negative 4 times negative 4 times negative 4, because it's a cube,
Negative, it would be negative 64.
yep. So you can take the cube root of a negative number then.
Oh, you can.
Yeah.
But you can't
Oh,
take the
but you
square
can't
root
take
of
the
a
square
negative.
root of a negative
Right,
number.
negative,
Okay,
negative,
that's where I
negative.
got
Yeah.
confused. That's where I got confused.
Okay. But like you just said, we can't take the square root of a negative, right? So the square root of a negative is not a real number. Okay? Not a real number. Can't do that. Okay? But cube roots are okay because of that whole idea of a negative, negative, negative.
Isn't that where the I comes in?
Yep, that's where the I comes in. We're not going to worry about that till chapter whatever is next, 6.
Oh, no.
This isn't enough?
It's plenty. I was kidding. I was definitely kidding.
What if we had the, I think we're okay. What if we do, let's talk about graphing these. It's not that bad. Okay, so I'm going to zip back over here, back into Desmos now. Alright, and we're going to graph a square root function. So I'm going to go y equals the square root of x, just plain old square root of x. Okay. So when we graph the square root of x, this is what we're getting. A curve that starts here at 0, rises, and then kind of flattens out, actually, is what it does. So first of all, let's ask, why is it starting at 0 and doesn't go any further? This
Okay, wait.
direction.
Well, how do you do it on decimals?
Just like
Find the
y,
square root.
just like that. Y equals the square root of x.
The check mark.
Yeah. So why does the graph start here rather than back in this area? Yeah, you can't square root negatives, right? Okay, so that's where it's going to start at. Okay, it's always going to start, well, I shouldn't say that, but it's going to start there. And you can see that it just kind of keeps going and going, all right? And it really kind of levels out. But it increases, it just slowly, all right? So the domain of this then, right, domain is x's. So if we fold this curve down on top of the x-axis, the domain is going to be all numbers that are
Greater than 0.
greater than 0. Yep, good. Okay, let's try this one now. So let's go here. I'm going to go -4. So what did the -4 do now? Shifted it. Good job. So it shifted it how much? 4 units. Aha. So now what's my domain?
Anything greater than 4.
Anything greater than 4. Okay? Anything greater than 4 is what the domain is. All right, so let's try that.
-4, wait.
Wait, what?
Mine says -4. What I do wrong?
What do you mean yours says negative?
Plus 4?
No, I put x minus 4.
Did you put y equals square root of x minus 4?
Y equals square, maybe the square didn't go over the 4?
Yeah, it could be.
Well, how do I make it go over the 4?
Just backspace it.
Backspace it?
Yeah.
Hey, let's try
Okay.
plus 2.
Got it. Thank you.
Yep. What about plus 2?
Everything greater than -2.
Everything greater than -2. So what did the plus 2 do to it?
Push it back.
They're negative.
Shifted it backwards this way. Okay. Plus 2 is going to shift it back this way. Minus would shift it that way. It's kind of the opposite, but that's how it works. Right. So that's the domain of those. Let's see. I think you're going to have some like that. Okay, here's another one. I did 2x plus 3. Again, it's shifting it back, but it's not shifting it back 3. It's shifting it back -1.5. If I click on that, I see that that's what it is. So that domain would be everything everything
No.
everything
Greater than 1.5.
greater than 1.5. That's what I was looking for. Somebody to fill me in there. You're just kind of going like this. Yeah. My goodness. How about this? Y equals negative square root x minus 4. Is the domain any different?
It's upside down.
Just upside down, right? The domain doesn't change. It's still
Yep.
greater than 4. Okay. Okay, here's 5 minus x. Is that one any different? It's going the other way, right?
Less than 5.
That would be less than 5.
Is it because you didn't put an x first, it went the other way?
Mm-hmm.
Okay.
Mm-hmm. Yeah. Okay. Cool. So those are all the domain problems. I just don't. You can look on page 343. I don't know if there's anything here that you wouldn't be able to. You're doing some evaluating, some approximating, and some simplifying. This is the stuff that we did. Do you see anything there that you that concerns you on 343?
Maybe 21.
21. So we're doing the. So on 21 we want to do, let's see, evaluate the square root of, I lost it. Oh, there it is, x squared, right? So the square root of x squared, so what's going to happen there? What are we going to get?
X.
We're just going to get x, right? Now the x greater than 0 is just telling you that it has to be a positive number. That's all they're doing there. So you don't really need to pay too much attention to it. Do you see what I'm talking about, Gabby?
No, just the, what I'm looking at.
Are you looking
Well,
at?
I guess, they just have it written out differently in the book. which was the
They
other
have
thing.
this. They have a greater than sign there.
Yeah.
Yeah, that's just saying that x has to be greater than or equal to 0 because you can't take square root of a negative. That they're just doing that. Okay. Any other ones?